Cool. So technically that should be recording now. Awesome. So basically, my background is in electronics. After getting the degree, I've had multiple roles in doing mine sites, but progressively I went more into designing electronics for people. So here you can see a couple of the products. Top left is a cocktail maker. Basically, you could slide through, pick your own drink. So it's running some motors on that. Bottom left is a more recent one. So an internet controlled light switch. To the right is a light counter. So it's connecting to the internet. So if you do want to connect with me, I'm at the 2 links there, and I'll be sending through this presentation after we're done. So an important thing is probably what can you actually do with electronics? So I've copied a couple of the images from the previous slide just to talk through those for a minute. So electronics are all around us. With an understanding of those, you can rebuild or create anything in your head. An example being a coffee machine. There's multiple steps to a coffee machine, running a motor for a grinder, bringing something up to temperature, timing the perfect shot of coffee. So you can do all of those things in electronics. So electronics allows you to orchestrate quite a lot of things, to automate processes, and with the skill you would be able to diagnose, repair, and build your own devices. So today is just going to be a short session, and what we're going to do is number one, see how an LED works, have a look at what an Arduino microcontroller is. So that's how we're going to control the electronics using code. We're going to blink an LED, and we're going to have a little bit more look at it, at the code. So this is basically to orientate you to getting started in electronics. So the first thing that we're going to have a look at is how to blink, or actually just turn on an LED. So what we're going to do is there is an application called Tinkercad. I'm not sure if you've already familiar with it. I'll just see if I can open up the chat window for Zoom. Chat. Cool. So if you have any questions, feel free to throw them in the chat window and I'll get to them. So basically, Tinkercad, available at tinkercad.com, is going to be one of the tools that I'm going to show you to use. This is really useful because basically to get started with electronics, normally you need hardware, but instead we're going to be using the simulation online so that we can get started really easy. So if we are at Tinkercad, you can basically create a new circuit. And what we're going to do is we're just going to bring up a very basic circuit, one that lights an LED. So I'll just quickly step us through the circuit. Basically, it's just got 3 components in it. One is an LED, so a light emitting diode. This next is a resistor. So basically we slow down the current so that we, not slow down, we limit the current so that we only get enough for the LED. And we've got a coin cell battery providing our power. So if we start the simulation, you see that the light turns on. So this is the most basic form of a circuit. A circuit has a positive and a negative side. So basically an LED is a light emitting diode. So it is like, say your phone is a more complicated screen, and so which is effectively made of many LEDs. depending on what brand it is. So basically, we use these as indicators, so lights. The resistor here has got a color code on it. So you can look this up, but this one is a 220 ohm resistor. And so it's limiting the flow of current. So what happens, just briefly, is from the positive, it's not necessarily from the positive, but basically electrons move through the circuit. And you can see we complete it by coming back to the negative here. And this limits the current going through it. So this is a 3-volt battery. The LED requires less and less current, but basically this is a simple circuit. So I won't go too far into it because the purpose of today is to jump over to the code. But this is the type of circuit that we use to light an LED. So following on from that, LEDs do have a positive and a negative side, so it doesn't matter which direction you hook up the battery to. So basically in Tinkercad, you could play around with that. And if you change the resistor down too low, you'll burn out the LED, so you'll allow too much current through. So this is the main part that we're looking at today. So if you're not already familiar, this is an Arduino. An Arduino is basically a microcontroller, which is a small computer, very simple computer. So here's the major brains of it there. And we provide power either through this DC jack or through USB 5 volts. And what it allows us to do is write code to it. Code is a set of instructions, and then it allows us to manipulate or change the inputs and outputs, which is available through these pins on the side here. Additionally, we also have ground and power, and depending on which pin it is, they have different purposes. So say this 13 one is either on or off. This one with the tilde on it is something called pulse width modulation, which means we can turn it on and off at a very specific rate to basically to either simulate a certain level. If you put an LED on it and you did pulse width modulation into it, you can vary the brightness of it. Even though it's an on or off signal, it is it will look like the brightness is going up or down. Here's RX and TX. This is for serial communications. Analogs, you can set that to any voltage within a range. And then we've got some of the power. So I'll just go back to sharing the whole desktop. So now this basically gets to the main part, which is running the simulation of the Arduino on the computer. So what you're going to find is, I'll go through this briefly, but you'll be able to go back into Tinkercad and play around with it. So that's where you're going to learn the most. So here we've got an Arduino. The 5 volts is not plugged in yet, so the USB is not plugged in. But what we've got is we've got that same LED style circuit, except instead of a battery here, it's plugged into pin 13. So pin 13 is an I/O, so an input or an output. And so it's either on or off. And you can start to see the same circuit that we saw before, where say if this was on, then the power is applied, the current flows through the resistor, goes through the LED and completes the circuit to ground here. But basically, it's not controlled by a battery. It's controlled by the microcontroller, so the brains of it. Here we've got the code that's going to be run. So I'll push go on this, and we'll see what happens, and then we'll work out why. So we see that the light is turning on and off. So one thing about the Arduino is this light is also connected to pin 13. So it's used as a diagnostics item. So you've always got an LED. This is just an external LED that we're doing here. So let's have a look at the code. And so I'm going to go through this at a very basic level so that we can like understand and get it, should I say. So I'll just bring up the chat in case you want to ask some questions. So the first part here, so code is written in a very particular way, and it gives us certain functions. So when we do /*, it's the beginning of a long comment, and a // is an end of a comment. So when you see this particular color, these are comments. So that's a comment. This is a single line comment, which is a // is another single line comment. And you can also do single line comments after code. So this is just telling us what it's doing. In Arduino, we have two main things that always happen. So we've got a setup and we've got a loop. The setup always comes first and is always run once. And we use this to set things, set our environment a certain way. So as we read down, what happens is we hit this setup first and it runs this command. I won't go into the void part, but basically this is the setup function, and what's run is inside the parentheses. The tab in is just for making it pretty. This language is C, so you don't need to tab in, but it's good standards. So pin mode asks the Arduino to change the inputs and outputs, and it says it takes two parameters. So you'll be able to look this up after. I'll provide a cheat sheet to be able to do it, but there's certain functions that we use. We keep using them. Basically, everything in electronics and coding is made out of building blocks, and this is one of them. So 13 refers to this pin, and we want to set it to be an output. The reason we set it to an output is we've got a choice on this one. It can either be an input or an output. Output is used for driving LEDs, motors, speakers, say. Inputs are used for driving buttons. Not driving buttons, but reading data back from buttons to see what state the button is in. So that's in our next example after this one. So now that we've set it as an output, we're done with this. And now we go into this thing called a loop. Loops run continuously. Right? So basically what happens is it runs through it and then exits out the bottom, comes back in the top, and then does it again and again and again and again, forever. There's no exit condition here. So it will continuously run. So that's one of the nice things about microcontrollers. You set them to do a job and they'll do it for forever. So we've got a comment here and it goes, turn the LED on. So high, you want it to do. So here's one of the building blocks again. It's a function called digital write. And what digital write does is it takes a pin and it takes a state, or a level, should I say. And so it goes pin 13, turn it high, which is on. And so you can see the LED turns on. The next one is a delay. So the function delay just says, go into this and wait until a certain amount of time has elapsed. So it's the input to this function, so inside the parentheses, the brackets, is 1,000. The thing about writing in Arduino is we're talking, the default in here is in milliseconds. So there's 1,000 milliseconds to a second. So you can see that by milli. So if we put 1,000 in there, it's going to be 1 second. So it's turned it high, and then we've waited 1 second. And then there's another comment that says, now we're going to turn it off. And now we've got that same digital write again. So digital means it's either high or low. And we're talking to pin 13 again. And this time we request that it goes low. So you can see the LED turns off. The next command is that wait again. So we wait another second. And then we're done with this and we come back around. So you can see what it does. Let's run through it in a quicker way. So we turn the LED on or high, we wait a second, we turn it low, we wait a second, and then it comes back around, and we turn it high again, we wait a second, turn it low, wait a second. All right? So, and you can see that's exactly what's happening here. So the LED is effectively blinking because of this code that we put and the setup that we did. So if we did 2, sorry, I got to stop the code. If we did 2 here and we did 500, so that's half of 1,000. So what we should see is it'll go high, it'll stay high for 2 seconds, it'll go low for a very short amount of time, and then it'll stay high again. So if we run that, and 2, and back on, and you can see the LED is blinking in a different manner. So that's the most simplest code example that we've got. If you have any questions, let me know. Otherwise, I'll move on to the next one, which is we're going to use a button. So this is simply an output, and we're controlling an LED. And the next one is going to be a button. All right, so no questions have come through, so I'm just going to move on to the next one. So this one is a little bit different. So what we've got here is pretty much the same thing, but with the twist. Sorry, just trying to get my mouse right. So we've still got the LED connected to pin 13 and then the ground, but then we've got this thing going on over here. So I've also colored the wires in a particular way. So black means ground, so say negative or the finish of the circuit, and red is power. So in this case, it's 5 volts, V for volts. And we've got a button, and then we've got basically a signal that goes into 7. So what's happening here is, okay, the thing that's not visible is how the button is functioning. So it basically closes a circuit one way and then closes it another. If we run the code, we'll have a look and we'll diagnose it on the way back through it. So what we've got is the button. When the button is pressed, the LED comes on. So I just want to pause the screen sharing for a minute, and I just want to make sure that I'm sharing the right screen. Cool. It's probably going to be without the comments. So what's happening here is we've got power that comes in, and then it is effectively only shunted to 7 when I push the button. So this switch is normally it's connected this way, but when I push the button, it connects this way. And we can see this through the code. So we've got a lot of the same elements. We've got 13 as an output for the LED, and we've got digital write high and digital write low, except we've got maybe two other things in here. We've got pin 7 is now an input, so we're reading the state. Is it a high voltage or a low voltage? So is it 0 volts or is it 5 volts? So we'll be reading it. It's not reading it actively, it's just configured here, because that's in the setup and that's only run once. The next part down here is an if. So we use ifs if we want to ask it effectively a question. If what's in here is true, then we run the next line. Otherwise, else, we run this line. Right? So it's simple. It's like someone asking you a question. If it's sunny, turn off the light. If it's dark, turn on the light. So this is how we construct that. So if, and then we ask it a question. Digital read, so now this is the opposite of the digital write. So we read pin 7 and we say, is it equal to, but this is special, right? So it's not like normal math. We only do a single equals. In here, when you do a single equals, it means assign it, like make them equivalent. Double equals means compare it. So is digital 7, so this pin, compared to high? Is it true or false? So this evaluates to true or false. If it is true, then we run what's in the next bracket, which is make it high. If it equates to false, we run what's in the else. So it's low. So we can see that in its normal state, it is low. The LED is off. But when we push the button, you can see the LED turns on. So this gives us another method of control. The first one was a time delay, and now this was a button, and also we've got an if. So we can do conditional things. So you can even put counters in here. You know, if it gets to a certain number of counting, then we stop doing something or start doing something. It basically starts expanding what you can possibly do. So I'll just check the questions again. Cool. So we've had a look at the loop, the main loop, the delay, and on and offs. So I'll be sending out this slide pack, and basically it has links to these simulations that I've just gone through. And that's the simulation for the other one. Cool. Did we have any questions? No? No questions? Awesome. Oh, either way, I'm happy to answer. So I'll just look to finish it all up now. So basically, for going further, I do have a course online. I'll send you the link for that. If you do want to purchase an Arduino, there's some links on Amazon that you can get one through. There's also a cheat sheet for coding. So basically running through how to do a couple of the things. So here it is here, but I'll send you a copy. When you slowly progress through it, you'll be able to pull out the certain sections that you need. So here's that if that we talked about. So if a condition, if it's true, it does the first one. If it's false, it does the second one. You can keep compounding those ifs. So if, else, and then you put another if in there, else, and so you can create things like that. So that's all that I have at this moment. If you do want to contact me, I'm available on these two sites, so on LinkedIn and on my own site. Basically, what I'm looking to do here is basically help people get their ideas into reality with respect to electronics. And I'm just looking to use my background to be able to do that. So I'll be putting on more classes and answering more questions. Feel free to push reply to the email that I had sent earlier, and always looking to lend a hand. So appreciated. So I'll just stop recording.